All right, good morning. We have a review assignment that we're going to complete to work on simplifying radicals. One of the things that we're going to review, first of all, is the objective when we're actually simplifying radicals. The idea behind that is that what we're searching for within the square root are some different factors. So right now, what you should be seeing is a series of what are called the square numbers. And these are the factors that we're looking for. The square numbers are numbers that are designed as follows. The sequence it goes, the first one is what 1 squared is, which is 1. The next one, 2 squared, which is 4. 3 squared, 4 squared, and so forth. So when we're at 4 squared, we should have 16, right? And so on and so forth. The reason that these are handy is that when we're actually trying to simplify a radical, what we may have is the following. Take, for example, the square root of 50. The square root of 50, and 50 is not a prime number, it's composite. Prime numbers only have 2 factors, one in itself. Composite numbers have a multitude of factors. What we're looking for here is 2 factors within 50, and we're going to keep it inside of the radical, that we can make one of them into a square number. So looking at 50, we're going to start to consider these factors like 1, of course, which goes in, but that doesn't really help us. 1 times 50 is still just 50. But consider 4. Now 4 does go into 50, but it doesn't do so evenly. 9 doesn't go in evenly, right? Because think about the factors of 9, 18, 27, 36, 45. But even once we get past half of the number, right? Is if you think about even numbers, 2 is always going to be a factor, right? So if we were to take that number divided by 2, half of it is going to be kind of the largest factor, that's a whole number factor that we're going to have. So in this case, even take 50 divided by 2, what you're going to wind up with is 25. And we have 25 times 2, right? And really when you have radicals, and I'm going to take all the steps when we do these, when you break it into 2 factors, what you effectively have is the radicals separated into separate radicals. So the square root of 25 and the square root of 2. Of course, the square root of 25 is just 5. And we're going to multiply that times rad 2, which we've discussed before in the class. You know, thanks to the Pythagoreans, it's just an irrational expression, or it's an irrational number. It's the rational expression is just rad 2. So we're going to leave this guy just like this. It's going to be simplified as 5 rad 2. Whenever we can simplify, we will. We're going to make sure we leave these things just like that. The next one. Let's take something like rad 8 times 2 rad 4. So rad 8 times 2 rad 4. When you have rad 8, that guy can be broken up. Now there's a couple ways to handle this particular thing. So let's work with each individual radical. This guy is going to be broken down to 8, which would be of the square numbers, right? 1 doesn't matter. 4 is a factor of 8, right? 4 times 2. And we're going to leave the other guy alone, 2 times rad 4, okay? Now, rad 4 times 2, remember, we can just say that that is just like rad 4 times rad 2. We'll pull that rad 4 out, okay? That guy's just going to be a 2, and that's going to be times the square root of 2, okay? Still times 2 rad 4. Now, we can resolve the other side. We have 2 rad 2 times 2 times, well, the square root of 4, right, is going to be just 2. Now look what we have here. We have 2 times rad 2 times 2 times 2. All of those integers can be multiplied together. 2 times 2 times 2 is 8. And then the radical, of course, just by itself, so it's 8 rad 2. Remember, we can mix variables into this, and we will. For example, we have rad 18, a to the 5th, b to the 4th, c to the 7th. You'll hear this mantra from me throughout this course. First deal with the numbers, then deal with the letters. So let's first do that. Let's first deal with the integer portion of the term, 18, and then we'll deal with the variable portion of the term, a to the 5th, b to the 4th, c to the 7th. So again, first deal with the numbers, then deal with the letters. Now let's break up 18. 18 would become two things, right? Two factors. One of them has to be a square number, 1, 4, 9, 16, 25. Well, 16 is already more than half of 18. 25 is greater than 18, so those are out of the question. So 1, 4, 9, yeah, 9 will work, right? 9 is going to be a factor. Of course, we still have a to the 5th, b to the 4th, and c to the 7th. Take the square root of 9. Right? It can come out. It's going to be just 3. Now stuck inside, I have 2, a to the 5th, b to the 4th, c to the 7th. Now, quick little vocab thing. This guy right here, the radical symbol, this is actually called the Radicand. If you hear me actually utilize that term. It's a common mistake I've seen in some of your work already. Some of you guys are disregarding that, especially with regard to the distance formula. Make sure that you don't just forget that that's happening there, because it's essential to make sure that we're doing this correctly. Now, little sidebar over here. If we had the square root of a to the 4th, right? What we have here on the Radicand, there's like a little implication here. When there's nothing, it means that we're taking the second root or the square root. When we do that, remembering that multiplication, radicals are kind of exponents, there we go. Exponents are a shortcut for multiplication. And to undo those is when we take the root. If you remember that if we were to take, for example, a squared times a squared, we keep the same base of a, but all we have to do is just add these radicals to get a to the 4th. Okay? Now, going in the other direction, when we take the square root, we're really just dividing this exponent by 2. So this is just going to be a squared. Same deal is happening here. Let's take the square root of a to the 5th, right? That's what we're doing right over here. We have to take the square root of a to the 5th, b to the 4th, and c to the 7th. Well, again, remember this little magical 2 that's here. Well, think about this. This is the same thing as a to the 4th times a on the inside, right? A to the 4th times a, this is like a to the 1st. That would give us a to the 5th. The square root of a to the 4th is a squared. And the thing about taking the square root of a by itself is it's stuck inside. Or think of it like this. 5 divided by 2, which is 2, remainder 1. Okay? Or a squared, remainder a. The a is stuck on the inside. So let's apply that over to our work over here. So we have the rad 3. Sorry, I'm going to move the Radicand over to make room, right? We had a to the 5th, which gave us a squared, and the a is still stuck inside. And remember, the 2 was still right here, right? So that's still stuck inside. And we have the a. The square root of b to the 4th, well, 4 divided by 2 is just 2. So the b squared comes out. There's no remainder. But c to the 7th, that's where we're going to have a remainder. Think about this. 7 divided by 2, which is 3, with a remainder of, sorry about that, 3 comes out with a remainder of c on the inside. Let's try another one. The square root of 20, x to the 3rd, y to the 5th, z to the 6th power. Okay, so thinking about what gets stuck inside the Radicand and what gets to come out. Factors for 20. Now people mess this one up all the time. They go, oh yeah, it's 2 times 10. That is incorrect. You cannot do that, right? Because if you pull a 2 out, it implies that you took the square root to get the 2 outside, which means we took the square root of 4. 4 times 10 is 40, not 20. So that's not right. What we're looking for, again, factors of 20 that are going to give us factors of 20 where one of them is a square number, so we can take it out. So 4 times 5 will work. 4, square root of 4 is 2, and the 5 is stuck inside. Remember, we're going to divide each of these exponents for each of those variables by 2. So in the case of 3, 3 divided by 2 is 1, remainder 1, right? X to the first, which we don't have to write x to the first. Y to the fifth. So 5 divided by 2 is 2. Remainder 1, so the remainder of y is stuck inside. And then z to the 6, so 6 divided by 2 is 3. So that guy comes out, and there's no remainder, right? So nothing is remaining stuck inside the radicand. That's your answer. All right. Think about this guy. The square root of 49 divided by 36. Well, remember what this means. It's like saying the square root of 49 over the square root of 36. What's the square root of 49? It's 7. What's the square root of 36? It's 6. That's your answer. You can leave it just like that. Remember, we can leave improper fractions. There's no need to convert it. I mean, I guess you could. It could be 1 and 1/6, but I don't need you to do that. Okay. Next, we can rationalize, and you'll do this a little bit in Algebra 2. You'll rationalize both numerator and denominator, but for the accepted form we have, we cannot leave answers like this. We cannot leave it with a radical in the denominator. So here's what we're going to do. We're going to multiply times 1. Here's what my 1 looks like. Ready? Isn't that 1? Right? Isn't anything divided by itself equal to 1? Rad 5 divided by rad 5 is 1. You can multiply anything by 1, and it doesn't change the effective value of whatever you have in the first place. So we're not really changing anything here. Right? But we're going to do a conversion. This happens when we multiply, and what the key was is we were trying to match these denominators, because anything where you take the square or multiply by itself of a square root, it gives you whatever the original was. I love multiplying fractions. I think it's the easiest of the algorithms with dealing with fractions. Like, we're just going to go straight across. 3 times rad 5 is 3 rad 5. And then rad 5 times rad 5, well, remember, it's just going to be 5. It's what we initially started with, squaring a square root. If you don't believe me, rad 5 times rad 5 was rad 25, and rad 25 is equal to 5, right? So it's pretty straightforward, I think. Let's do another one of those. How about 2 over rad 3? Well, we need to multiply by 1. So let's multiply by 1. What does our 1 look like this time, though? Our 1 would look like this. It would be rad 3 over rad 3, right? Remember, rad 3 divided by rad 3 is just 1. Anything times 1 is still itself. So we're not, again, just making anything up. And then we're going to multiply here. 2 times rad 3 is 2 rad 3. And rad 3 times rad 3 is 3, right? Square root of 9. Is 3. Let's do a fun one. Are going to get progressively more exotic as we go. We have rad 17x over rad 20. Well, step 1, let's multiply by 1. Why not? Remember what our 1 looks like. We're just going to take that denominator, we're going to duplicate it, same thing over itself, right? Because the goal here, it actually has to do with the denominator, not the numerator. What rad 20 times rad 20 is 20. So now our denominator is an integer, and that's great, okay? Now, rad 20 times rad 17x, if you need a calculator, that's fine because you need to do 17 times 20. You might be able to do that in your head, which is rad 340x. And some of you might be satisfied right there. You might be thinking, oh yeah, I'm done, but you're not, okay? Let's see if 340 has any square numbers inside of it. And as it turns out, it does. 4 is a factor of 340, which shouldn't be too much of a stretch of the imagination, right? 4 is going to be a factor of 100, therefore it will be a factor of 300, and 4 will separately be a factor of 40, right? So yeah, of course it works in there. 340 divided by 4 is 85. So we can pull that out of the Radicand, right? The 2 can come out, but the 85x is going to be stuck inside. And of course, on the bottom, I still have 20. Can I factor? But of course, look, right? This becomes a 1 and this becomes a 10. So our real answer here is rad 85x all divided by 10. It was never going to be rad 17x over rad 20. Okay, our last concept here with reviewing these things is this. We might have a Messier denominator, right? Look at something like this, 8 over 6 minus rad 3. Now I can't just multiply by rad 3. It's not going to work out, okay? So a little sidebar here, just remembering something. We're going to utilize what's actually called the conjugate. The conjugate comes from this concept. Think about this. If I had x minus 7, and I multiplied that times, instead of x minus 7, x plus 7, and as a quantity. You guys remember this when we did multiplying binomials, right? Foiling. Well, what's great about this is usually when we multiply binomials, we come out with 3 terms, right? Like x squared plus something x plus or minus something at the end. But we're not going to have that here. Watch what happens. We have x squared, and we'll have a plus 7x, and we'll have a minus 7x. Those guys are going to cancel each other. All we really have to do when we multiply a difference of 2 squares is multiply the first terms and then multiply the last terms. So I only have 2 terms, not 3. That's the idea we're going to use with the conjugate. Let's come back over here and figure out what our conjugate is going to be. If I have 6 minus rad 3, the conjugate is going to be 6 plus rad 3. And remember, I want to multiply times 1, correct? So then I need to make my numerator and my denominator match. Because now I'm not really effectively changing the value of it. I'm multiplying by 1, so that thing is still, this has the same value. Now, here we go. Ready? 8 times 6 is 48. 8 times rad 3 is 8 rad 3, so plus 8 rad 3. That's the numerator. And think about what we just did. I can walk you through this whole other thing, right? Where we have 6 times 6 is 36. Now, I'm only going to do this once, just to show you that it happens. I have 6 plus rad 3. I'm sorry, plus 6 rad 3 and minus 6 rad 3, right? When I did FOIL, I did first, outer, inner, right? 6 times rad 3 is 6 rad 3. Negative rad 3 times 6 is negative 6 rad 3. But guys, remember, that's just going to cancel. And of course, the last when we FOIL, right? Negative rad 3 times rad 3, which is minus 3. Right? Negative times a positive. And then we have rad 3 times rad 3, which is just 3. Check it out. 48 plus 8 rad 3 all over 36 minus 3 is 33. That's your answer. One more of these with the conjugate, okay? We have 3 over 5 minus rad 2. Take a look at the bottom. That's where we're going to get our conjugate. We should have 5 plus rad 2, right? That's your conjugate, which means the same numerator has to be matched to make this multiplying times 1. And this should be super duper quick, right? Step 1 is I'm going to multiply the numerator. So I'm going to distribute 3 times 5, which is 15, and 3 times rad 2, which is 3 rad 2. Now we do the bottom, the denominator. And remember, I have a difference of 2 squares when I use that conjugate, so that way I only have to do really the first and the last. I don't have to worry about outer inner with FOIL, because they're going to cancel each other anyway. 5 times 5 is 25, right? Again, 5 times rad 2 is 5 rad 2. Negative rad 2 times 5 is negative 5 rad 2. It cancels each other. So all I have to do is negative rad 2 times positive rad 2, which is going to give me minus 2. And then you simplify. 15 plus 3 rad 2, all over 25 minus 2, which is 23. That's your answer. I'm going to post your assignment onto Canvas. Good luck.